Hey you! What you're about to watch is a compilation of the 8 individual videos that make up the TypeScript narrowing series. If you have already seen the 8 individual videos, there's nothing new here. If you haven't, watching this compilation will be faster than watching the 8 individual videos because we have removed the transitions between a video and another. Also, if you prefer to read the content instead of watching videos, you can go to lucaspaganini.com. We always publish our videos as articles on our website. While you're there, you can also subscribe to our newsletter to be notified every time we launch a new content. The video starts now. Good morning, night, afternoon, whatever time it is right now. And welcome! Welcome to the first video in our TypeScript narrowing series. We have so much to cover, going from the fundamentals all the way up to advanced use cases. In this series, we will cover what is a type guard, what is narrowing, what problems does it solve, type guard operators, equality narrowing, truthiness narrowing, control flow. At this point, you probably don't even know what I'm talking about. And that's fine, you will get there. But first, subscribe to the channel to make sure you don't miss any future videos. And a narrowing library. I am Lucas Paganini, and in this channel, we release web development tutorials. If that's something you're interested in, please leave a like and subscribe to the channel. Let's start with the concepts. What is narrowing? Narrowing is the process of refining a broader type to one that is more specific. For example, refining string to ABC, or number to 1, 2, 3, and so on. You have a broader type and you shrink it to something more specific. And why would you do that? Well, to handle the cases individually. If you have a variable that can be a string, a number, or a boolean, then you probably want to handle those cases one by one. If it is a string, do this. If it is a number, do that. And if it is a boolean, do this other thing. That is narrowing. You have a broader type, which is the combination of string, number, and boolean. Then you narrow this broader type to just a string, then to just a number, then to just a boolean. To narrow the types, you can use type guards. And what is a type guard? Type guards are narrowing techniques. They allow you to do narrowing. Lucas, let's be practical. How do they look like? Show me a type guard. Okay, I'll show you. Just bear with me for 1 minute, okay? I want to emphasize 2 things. First, TypeScript is a superset of JavaScript. All JavaScript is valid TypeScript, okay? Second, TypeScript wants to be as little intrusive as possible. Instead of forcing us into a new syntax, it will support idiomatic JavaScript ways of doing things, when possible. See, narrowing is not a new issue. We've had to deal with it in JavaScript for years now. I'll bet that you were thinking of the typeof operator while I was giving the last example. The typeof operator allows us to narrow our types. So, it is a type guard. And there are many other type guards. You can also create your own. We also have assertion guards, which is another way of doing narrowing. And for this video, I'll leave it at that. References are in the description. You now know the concepts of narrowing in TypeScript, but don't get used to it. In the next video, we'll get our hands dirty and practice those concepts. I can't emphasize enough the amount of topics that we need to cover. There is a lot to come. And breaking that down to you in easy lessons, full of examples and animations, takes a lot of work. So I will play the role of the annoying content creator here and kindly ask you to like and share this video. Share it with your colleagues, share it in a Facebook group, share it on Reddit, I don't know, but help us grow so that we keep making premium content like that for free. In this video, I want to show you the fundamental type guards in practice. To do that, we will build a function that formats error messages before showing them to the end user. Our function should be able to receive multiple different types and return a formatted error message. Are you ready? We'll start by supporting only 2 types, string and error. To implement that function, we need to narrow the string or error type to just a string and deal with it. Then we narrow to just an error and deal with it. The first type guard that we'll explore is the typeof operator. This operator allows us to check if a given value is a string, number, big int, boolean, symbol, undefined, object, or a function. So let's use it in our function. What's happening here is that the typeof_value equals string statement is acting as a type guard for a string. TypeScript knows that the only way for the code inside that if statement to run is if value is a string, so it narrows the type down to string inside the if block. Since we're returning something, value can't be a string after that if statement, so the only type left is error. Sometimes we're not so lucky. For example, let's add a new type to our function, a custom interface called warning. Now our code is broken. Before, our value variable could only be an error instance after the if statement, but now it can be an error or a warning, and the message property does not exist in a warning. The typeof operator won't help us here, because typeof_value would be object for both cases. One of the idiomatic ways of handling that situation in JavaScript would be to check if value has the text property. If it does, it's a warning. We can do that with the in operator guard. This operator returns true if the given object has the given property. In this case, if value has the text property. TypeScript knows that our if statement will only be true if value is a warning, because that's the only possible type for value that has a property called text. So it narrows the type down to warning inside the if block. After the first if statement, value can be either a warning or an error. After the second if statement, it can only be an error. It's also very common to support optional arguments. That means allowing value to be null or undefined. We could handle the undefined case with the typeof operator, but that wouldn't work with null. By the way, if you want to know why it wouldn't work with null and the differences between null and undefined, I have a very short and informative video explaining just that. I'll leave a link for it in the description. What we could do that would work for null and undefined is to use equality operators, such as equals. Our if statement will only be true if value equals null or undefined. So TypeScript narrows our type to null or undefined. That's called equality narrowing. And it also works with other comparison operators, such as not equals, and lose not equals. But here's the thing. Equality narrowing is not the idiomatic JavaScript way of checking for null or undefined. The idiomatic way of doing this is to check if the value is truthy. I have a 1 minute long video explaining what is truthy and falsy in JavaScript. I'll put the link on the screen and in the description. It would be nice if you could go watch that real quick so that we have the definition of truthy and falsy fresh in our minds. Go ahead, I'm waiting. Okay, now that we all have the definition of truthy and falsy fresh in our minds, let me introduce you to truthiness narrowing. Instead of using equality narrowing to check if value equals null or undefined, we can just see if it's falsy. We can do that by prefixing it with a logical not. That will convert the value to a boolean and invert it. If it's falsy, it will be converted to false and then inverted to true. So far, we've been avoiding a guard to check if value is an instance of the error class. I told you how we're managing to do that. We are treating all the possible types so that there's only the error type left in the end. That technique is very common in JavaScript, and it's also a form of narrowing. The correct term for what we've been doing is control flow analysis. Control flow analysis is the analysis of your code based on its reachability. TypeScript knows that we can't reach the first if statement if value is not falsy. We can't reach the second if value is not a string. We can't reach the third if it's not a warning. So in the end, there's only one type left. It can only be an error. Those types are being narrowed because TypeScript is using control flow analysis. But we don't need to rely on control flow analysis to narrow our type to error. We can do it with a very simple and idiomatic JavaScript operator, the instance of operator. Here, we are checking if value is an instance of the error class. So TypeScript narrows our type down to error. There is no type left after that last if statement. We will never reach any code that comes after it. If you're wondering what TypeScript considers to be the type of value after all of our if statements, the answer is never. Never is a special type that represents something that is impossible, something that should never happen. Those were the fundamental type guards. They are super useful, but they will only take you so far. In the next videos, I'll show you how to create custom type guards. Subscribe if you don't want to miss it. References are in the description. Now I'd like to show you type guard functions. For example, if you need to check if a variable called value is a string, you could use the type of operator. But what you could also do is create a function called isString that receives an argument and returns true if the given argument is a string. Remember our format error message function from the last video? Let's remove the type of operator from it and use isString instead. It's the same code. We just isolated the guard in a function, right? No, it breaks. TypeScript is not narrowing the type to string. The guard is not working. Here's the thing. isString is returning a boolean, and we know what that boolean means. It means that the argument is a string. But TypeScript doesn't know what the boolean means, so we need to tell it. Instead of saying that our function returns a boolean, we need to say that our function returns the answer to the question. Is this argument a string? Given that the name of our argument is value, we do that with the following syntax. Value is string. Now TypeScript understands that isString is a type guard, and our format error message function compiles correctly. The return type of our isString function is not just a boolean anymore, it is a type predicate. So, to make a custom type guard, you just need to define a function that returns a type predicate. All type predicates take the form of parameter is type. A quick tip before we continue. Instead of using the type any in our custom guard parameter, our code would be much safer if we use the unknown type. I made a 1-minute video explaining the differences between any and unknown. The link is in the description. Let's exercise our knowledge by converting all the checks in our format error message function to custom guards. We already have a guard for strings. Now we need guards for warning, error, and false types. The guard for error is pretty straightforward. We just isolate the instance of operator check in a function. But the warning guard, on the other hand, is not that simple. TypeScript allowed us to use the in operator because there was a limited amount of types that our value parameter could be, and they were all objects. But if we create a function and say that our parameter is unknown, then it could be anything, including primitive types, and that would throw an error because we can only use the in operator in objects. The solution is to make sure our parameter is a valid object before using the in operator. And we also need to make sure that it's not null. For the false values guard, we first need to define a type with values that are considered false. I'm not including nan here because there is no nan type in TypeScript. The type of nan is number, and not all numbers are false, so that's why we're not dealing with nan. There is a proposal to add nan as a type, and also integer, float, and infinity. I think that is really nice. It would be very helpful to have those types. I'll leave a link for the proposal in the description. Go give it a thumbs up if you think we should have the nan type in TypeScript. Anyways, now that we have our false type, we can create a false values guard. Remember, a value is false if it's considered false when converted to a boolean. So, to check if our value is false, we can use abstract equality to see if it gets converted to false. That's it. We now have all the custom guards that we need for our format error message function. Before we wrap this up, I want to show you something. There is a limited list of false values, right? But truth values, on the other hand, are infinity. All values that are not falsy are truthy. So how would you make a type guard for truthy values? The trick is to exclude the falsy types. Instead of checking if our value is truthy, we check that it's not falsy. I use this trick a lot, and we will see it again in future videos. References and other links are in the description. So, tagged union types. What are they? It's actually pretty self-explanatory. They are union types with a tag. For example, you could have a union type called log that aggregates three interfaces: warning, debug, and information. Cool, now we have a union type. To turn that into a tagged union type, we need a common property with literal types between our interfaces. It could be any property name, but to simulate a real-world example, we will call it subscribe to the channel. This property will serve as an ID for the different types of interfaces that make up the log type. Every interface will have a different literal type for that property. And that's it. The subscribe to the channel property is serving as a tag for the log type, so it is now a tagged union type. As I've mentioned before, this is also known as a discriminated union, and our subscribe to the channel property is the discriminant property of log. To quote from the TypeScript docs, when every type in a union contains a common property with literal types, TypeScript considers that to be a discriminated union. So from now on, I will use the discriminated unions terminology instead of tagged union types, because that's how TypeScript is calling it nowadays, and I want to be consistent with the official terminologies. Even though I believe that tagged union types would be a better name for it. Okay, Lucas, I got it, but what's the point? What do I get with a discriminated union? Good question. What you get with a discriminated union is a type guard for all the possible discriminations of the union type. For example, if you have a variable called value, that is a log, that means that value could be either a warning, a debug, or an information. But instead of creating individual guards for those three interfaces, you could check the value of the discriminant property. If subscribe to the channel is like, you know that it's a warning. If it's comment, it's a debug, and if it's share, it's an information. And you can make your code even clearer by going an extra mile and switching your if statements. Got it? Switching? Switch? No. Okay. References and links for the previous videos are in the description. If you enjoyed the content, you know what to do. In this video, I'll show you assertion functions, also known as assertion guards. I'm Lucas Paganini, and in this channel, we release web development tutorials. Subscribe if you're interested in that. The reason why assertion functions are also known as assertion guards is because of their similarity to type guards. In our type guard for strings, we return true if the given argument is a string and false if it's not. If we wanted an assertion function instead of a type guard, instead of returning either true or false, our function would either return or throw. If it is a string, it returns. If it is not a string, it throws. If you call a function that throws if your value is not a string, then all the code that comes after it will only run if your value is a string. So, TypeScript narrows our type to string. To abstract this explanation, TypeScript uses control flow analysis to narrow our type to what was asserted. In this case, we have asserted that value is a string. Now, when and why would you want to use an assertion function instead of a type guard? Well, the most popular use case for assertion functions is data validation. Suppose you have a Node.js server and you're writing a handler for user creation. The first thing you should do in your request handlers is validate the data. If any of the fields is missing or invalid, you will want to throw an error. When you have conditions to check at the beginning of your code and you refuse to run if those conditions are invalid, that's called an early exit, and it's the perfect scenario for assertion functions. If you want to know more about early exits, I have a 1-minute video explaining what they are. I'll leave a link for it in the description. Maybe you've noticed that I'm using function declarations instead of function expressions. There's a reason for that. By the way, knowing the differences between function declarations and function expressions is very important. I'm sure most of you already know that, but if you don't, it's okay. I made a 1-minute video explaining just that, and I'm leaving the link for it in the description. So, back to assertion functions. I'm using function declarations because TypeScript has trouble recognizing assertion functions during control flow analysis if they are written as function expressions. Function declarations work because they are hoisted, so their types are declared previously and TypeScript likes that. Personally, I think that's a bug and should be fixed, but I don't know if they're going to fix that. Currently, they say it's working as intended. To work around that issue, I found two alternatives. The first, using function declarations, and the second, use function expressions with predefined types. I prefer function expressions, so I'll go with the second option. For that, instead of defining our function signature along with its implementation, we will have to define its signature as an isolated type and cast our function to that type. Here's how it looks like if we wanted to use function expressions for our assert_is_name function. And we were also using an assert_has_props function to check that our object has the properties that we expect. Maybe you're curious, so I'm just showing it to you because I think that function has an interesting signature. I'm also leaving a link to the GitHub issues and PRs related to this if you want to know more. Before we wrap this up, I want to show you a different signature for assertion functions. Weird, right? There is no type predicate, so what the hell are we asserting? This signature means that the condition to check is already a type guard. For example, you could give it a type of expression and it would narrow the type accordingly. Assertion functions are cool, right? People are just not used to them yet. References are in the description. If you enjoy the content, you know what to do. Today, we'll grab a pattern from the functional programming world known as higher order functions and use it to create functions that receive functions and return new functions. But we won't stop there. We won't just return any new functions. We will return new custom type guards. So I'm calling those type guard creation functions higher order guards. As you soon find out, that will open the door for new possibilities of reusing our code. I'm Lucas Paganini, and in this channel, we release web development tutorials. Subscribe if you're interested in that. We also publish our content as articles on our website. You can subscribe to our newsletter and be the first to know when we launch a course, post a video, or write an article. The theoretical description of a higher order function is a tongue twister. Function that receives a function and returns another function. So, let me show you to you in practice and you will see that it's not as complex as it sounds. Let's say we have a lot of custom type guards and now we want inverted versions of them. We already have isString, now we want isNotString. We already have isNumber, now we want isNotNumber. You get the idea. We did something very similar in the end of our third video, when we wrote a guard for truthy values that works by excluding falsy values. We can apply the same technique to create our inverted type guards. That's how they would look like. But writing those inverted guards manually is tedious and repetitive. I bet you can see a pattern in them. All we need to create an inverted guard is the custom type guard that will be inverted. In other words, the only difference between isNotString and isNotNumber is that one is using the isString guard and the other is using the isNumber guard. Could we stop repeating ourselves and create a function that accepts a type guard as an argument and returns the inverted version of the given type guard? Hell yeah, we can! Let's do that right now. I have a personal convention of prefixing functions with the word make when they return new functions. So it makes sense to me to call our function makeIsNot, since it makes the isNot version of a type guard. the function implementation alone is already a bit tricky. So I'll navigate it with you before we get into the TypeScript signature. Let's use isNotString as an example. Calling makeIsNot with isString returns a function that receives one argument called v and returns the inverted return of calling isString with v. The same works for isNotNumber. Calling makeIsNot with isNumber returns a function that receives one argument called v and returns the inverted return of calling isNumber with v. All good and well with the implementation. Now to the type signature of makeIsNot. Oh shit, how am I supposed to explain this? Okay, let's break it down and see what can be simplified. First, there are two places where we are referring to a function that returns a type predicate. In other words, a custom type card. Let's create a type called typeCard function to isolate that type definition and simplify our code a little bit. It's a little better now, right? Also, even though the naming typeCard function makes a lot of sense, since it is indeed a typeCard function, this name is very specific to TypeScript. And it turns out that functions that receive an argument and return a boolean already had a name before TypeScript even existed. Those functions are known as predicate functions. So let's use the name predicate function instead. Also, not that it repeats, but that part where we are inferring the type of the predicate function is kinda ugly to look at. Let's isolate that in a type. By the way, if you are at a loss with the ternary operator and the infer keyword, I have two videos for you. They are both 1 minute long. One explains TypeScript conditional types, the ternary operator, and the other explains the infer keyword. I'll leave their links in the description. I have another personal convention, which is to use the prefix unpack when I am creating a type that infers something. So I'll call it unpack predicate function. Back to the signature. Okay, it's still not simple, but it is simpler. Let's try to analyze the signature now. First, we receive an argument, a predicate function called fn. Then we return a new function. This new function receives an argument called v, which has the same type of the first parameter of fn, and that returns a type predicate saying that v is not of the type guarded by our fn function. There are some limitations to our function. For example, right now it only works with guards that receive a single argument, and also it's not tested. If you are interested in having makeIsNot in your codebase, and also makeIsInstance, makeIsIncluded, and a lot more, instead of copying the code from this video, a better way is to just install my TypeScript utilities library. It's open source, has tests, documentation, works on Node and browsers, it's MIT, and you can easily install it with npm install at lucaspaganini/ts. We'll talk more about the library in the last video. Today's content was pretty advanced. I remember how hard it was for me to learn functional programming and advanced TypeScript notations. So we really did our best with the examples and animations to hopefully give you an easier learning experience than the one I had. I would love to have a feedback from you, so please leave a comment and let us know if you could understand everything, and your questions if you have any. References are in the description. If you enjoyed the content, you know what to do. Today, we'll talk about a highly requested feature in TypeScript, asynchronous type cards. We just have one small problem. It's still just a feature request. There is no official support for asynchronous type cards yet. But as developers, we can't just wait for someone else to fix our problems. Sometimes, most times, we need to find a solution ourselves, and with the tools we currently have available. And that is exactly what we're going to do. I will show you the cleanest workaround for asynchronous type cards that I could came up with. It is also a solution that will be easy to refactor once we do get support for asynchronous type cards in TypeScript. If you have a different solution, leave a comment and we can discuss it. I'm Lucas Paganini, and in this channel, we release web development tutorials. Subscribe if you're interested in that. We also publish our content as articles on our website. You can subscribe to our newsletter and be the first to know when we launch a course, post a video, or write an article. In an ideal world, we would be writing asynchronous functions that return a type predicate wrapped in a promise. We can't do that yet, but we can strive to get as close to it as possible. So, let's look for a workaround that is close to this ideal implementation. Also, you might be wondering, why would we ever asynchronously check if a value is a string? Well, I too wonder, why would we ever do that? The thing is, I have a real-world use case where asynchronous type cards would be useful, and I will show you that scenario. But I want us to first understand our implementation of asynchronous type cards. So let's stick with our fictional isString async function for now. We can't currently return a type predicate wrapped in a promise, but we can return a boolean wrapped in a promise. Now, as you might have guessed, that boolean means nothing to TypeScript. It performs no type narrowing in our variable. That is sad. It seems like we can only have synchronous type cards. But wait, in the last video, we learned that we can have functions that create new type cards. So, maybe we could have a function that asynchronously creates a synchronous type card. See, instead of returning the promise of a type predicate, which we can't do yet, what we can do is return the promise of a function that returns a type predicate. And holy shit, it actually works. And it is so close to the ideal scenario that it will be very easy to refactor our code once we do get native support for asynchronous type cards. Awesome! Now that we got the implementation, let's discuss a real-world scenario where it would really be beneficial for us to have asynchronous type cards. Because checking if a value is a string asynchronously is not a good use case. I'll give you an example inspired by the one that Dominik Glodek gave when he made the feature request for asynchronous type cards. You're writing an API endpoint that receives data to create a user. The user data consists of an email and a password. You can only save users to the database if they are valid. For a user to be valid, it needs to meet two criteria. First, the password should have at least 8 characters, and second, the email cannot already belong to another user. The first check could be done synchronously, so let's start with that. We will create an assertion function called validateUser that checks that our object complies with the user interface and with the password validation. Before we add our asynchronous validation to make sure the user email doesn't already belong to another user, let's see what would happen if we try to use our assertion function as it is right now. As you can see, TypeScript thinks it's all okay. There are no compilation errors. Save user to database is expecting a user, and that's what it's getting. But it doesn't know that this user has not been fully validated yet. Actually, TypeScript would think it's all good even if we didn't validate the password length. In short, TypeScript is only verifying that our value complies with the user interface. It is not verifying if it passes the validation criteria. Could we somehow tell TypeScript when a value not only complies with the user interface, but is also a fully validated user? Well, yeah, we can. We can create a secret property to indicate that the password length has been validated, and another to indicate that the email doesn't belong to another user. Also, we can have a union type called validateUser, which is equal to a user that has both validations. With that in place, we can change the signature of validateUser to assert that the value is not just a user, but a password validated user. And we can also change the signature of SaveUser to database to make it only accept users that have already been fully validated. With that structure in place, I am weirdly happy to say that our code would not compile. Yay! For it to compile again, we need to create an asynchronous assertion function using the same trick that we used for asynchronous type guards. Okay, I think we're good now. Calling validate user async returns the promise of a synchronous assertion function, which we then use to assert that the value is a validated user. Cool. Now we are protecting ourselves from performing database operations with unvalidated resources. That is a real use case for asynchronous type guards and a whole bunch of advanced TypeScript madness. And you know what? I love you. So I went ahead and made our lives even easier. I made an asynchronous higher order guard that creates asynchronous type guards for us. If you choose to use my utility function, it will be even easier to create asynchronous guards and refactor them once we get native support for them in TypeScript. It works on Node and browsers. You can install it with npm install at lucaspaganini/ts. I have a lot more to say about the library, but that's a topic for the next video, so stay tuned. References are in the description. I made a comment in the feature request for asynchronous type guards, explaining the workaround I came up with. If you don't mind, it would be great if you give a thumbs up to the feature request and to my comment, to give them more traction. The link for it is also in the description. If you enjoyed the content, you know what to do. Today, I'll show you an open-sourced library that I wrote using the same techniques discussed in our previous videos. This library is by no means rigid to anyone's workflow. On the contrary, I made it with the intention of it being valuable to anyone working on a TypeScript codebase. I'm Lucas Paganini, and in this channel, we release web development tutorials. Subscribe if you're interested in that. We also publish our content as articles on our website. You can subscribe to our newsletter and be the first to know when we launch a course, post a video, or write an article. Before we talk about what's inside, you should know how to install it and who should install it. I made this library available on npm. To add it to your codebase, simply run npm install at lucaspaganini/ts. Now, regarding who should install it, I see this library as Lodash for TypeScript. It provides you with flexible and type-safe utilities that make your codebase cleaner. Also, everything is isolated, so you can install it and only import the things that you actually want to use. That said, I truly believe that this library is useful for anyone working in a TypeScript codebase. Front-end, back-end, whatever. If you're using TypeScript, you will benefit from having those utilities. So without further ado, let's explore what's currently available in the library. By the way, I say currently available because it's a living thing. We will add more to it later. So far, our library has 3 modules: core, assertions, and predicates. Let's start with the core module. The core module contains those 6 utilities. Mutable is the opposite of the native read-only type. It converts the read-only properties of a type into regular mutable properties. Non-nullable properties is similar. It converts all the properties of a type into non-nullable properties. Then we have object values, which returns a union type of the types of all the properties in an object. So, if your object has 3 properties, being them a string, a number, and a date, object values will give you the string or number or date type. I can't tell you how useful that is. Pick property by type returns the keys of the properties that match the expected type. So, similarly to our last example, if we have an object with 4 properties, one being a string, another being a number, and the last 2 being dates, we could use pick property by type to get only the properties that are strings, or the ones that are numbers, or even the 2 that are dates. Similarly, pick by type returns an object that only contains the properties that match the expected type. And last but not least, make constraint allows us to set a type constraint and still keep the literal types. For example, let's say we have a type called icon. It contains a name and an ID. Both properties should be strings. Then we declare a read-only array of icon with 2 icons. one with the ID error and the other with the ID success. Now, if you try to extract the icon ID based on the type of icons, it will be string. But that's too broad. Icon ID should be error or success. If we remove the casting of icons to read-only array of icon, we get what we want, but then we lose the type safety of icons. That's where make constraint comes into play. With it, we can make sure that icons is a read-only array of icon, but still get its literal read-only types. Cool, now let's get into the assertions module. This module contains these 4 utilities. An assertion function is exactly what it seems, a function that makes a type assertion. Unpack assertion function returns the type asserted by an assertion function. Assert has properties, asserts that the given value has the given properties, and throws if it doesn't. To keep things safe, the asserted properties are typed as unknown. If you don't know the differences between any and unknown, I have a 1-minute video for you. The link is in the description. And the last utility in the assertions module is from predicate function. It takes a predicate function, which we'll talk about in a second, and returns an assertion function. The last module in our library is also the largest. The predicates module contains 11 utilities. The first one, predicate function, is a type guard. It takes a value and returns a type predicate. You may be tempted to call this a type guard, but as I've mentioned in the 6th video of the series, the one about higher order guards, the type guard naming is very specific to TypeScript. And these types of functions have been called predicate functions way before TypeScript even existed. Okay? Similarly to unpack assertion functions, we can use unpack predicate function to extract the type guarded by a predicate function. Sometimes we have predicate functions that don't return a type predicate. They just return a regular boolean. For those cases, we have the unguarded predicate function. For example, isEqual is an unguarded predicate function. Then we have the async predicate function, async unguarded predicate function, and make async predicate function. I won't go deeper into them because the 7th video of our TypeScript narrowing series was all about them, so I'm not gonna waste your time repeating information. Make is not was also mentioned previously in the 6th video. It takes a predicate function and returns the inverted version of it. Make is instance is new though. It takes a class constructor and returns a predicate function that checks if a value is an instance of the given class constructor. Make is included takes an iterable and returns a predicate function that checks if a value is included in the given iterable. And finally, just like in the assertions module, we have make has properties and from assertion function. Make has properties takes an array of properties and returns a predicate function that checks if a value has those properties. And from assertion function takes an assertion function and returns a predicate function. It's the end. But don't close the video yet, I have some things to say. This is the last video of our TypeScript narrowing series. The first video series I did on YouTube. I am super happy with the quality that we were able to put out, but I also have big dreams. I want to make things crazy better, and that's why me and my team are building a platform for interactive learning experiences. So, imagine consuming my content, and in the middle of it, there's a minigame for you, or a 3D animation, or a quick quiz to consolidate your knowledge. You get the idea. And all that available in many languages. We currently offer our content in English and Portuguese, but I also want to offer it in Spanish, German, French, and so many others. For now, we are releasing all that content for free. But I think it's obvious to say that we will eventually have paid courses. And I want them to be awesome, like deliver unbelievable value. So sure, if you haven't yet, I highly encourage you to like this video and subscribe to the channel. Your support is highly appreciated. But don't do just that, because the best way for you to keep up with all those things that we're going to do outside of YouTube is through my email newsletter. So go to lucaspaganini.com and subscribe to it. Thank you so much for sticking with me. I hope you enjoyed it, and I hope this is only the beginning of a long journey on YouTube and content creation in general. As always, references are in the description, and if your company is looking for remote web developers, please consider contacting me and my team on lucaspaganini.com. Until then, have a great day, and I will see you in the next one.